Now this is a recap from lecture last week where we talked about the idea of the population and the sample. And this is another really important thing to think about, is that we are not trying to prove anything about the sample. In fact, in our sample, we can quite validly say that the girls did text more than the boys, because the mean number was actually greater for the girls than the boys. It was a very small number, but it was greater. So we're not actually trying to draw any conclusions about the sample. We know what the sample says, and this is a really key idea. But what it is that from that sample, what can we say about the population? So that sample of 200 or whatever, we have not got evidence to say that there is a difference in the number of texts sent between male and female students. Okay, and generally, we don't know if we're correct or not, just like the confidence intervals. So with our inferences we may be, but we use our knowledge of probability. So what's happened is over the years these scientists have worked out what distribution is likely to happen in order for things to occur. So just like with the pinky bars, I could tell you what was the probability of getting 5 pinky bars in a row. And just in the same way, they've gone into normal distributions and other distributions and said, okay, with this distribution of male and female students, or these numbers, what's the probability of getting a value that far apart? And the answer was 0.81. So we're using our knowledge of the theory of probability in order to make conclusions about stuff that happens in the real world. So I guess I've got this summarised here. Is basically the hypotheses are always about the population. We know what's happened in the sample. Okay, in the sample, the female students did send more, but we don't have evidence that this result is also true in the population. The difference that does occur is due to sampling variation and natural variation. Because we took a sample rather than the entire population, it may not necessarily totally represent the population, and because there is natural variation, not everybody sends the same number of texts, that's why we can only draw inference rather than say for sure. Now, if every female student always sent 20 texts a day and every male student always sent 10, we'd only have to ask one of each, and we would know. But the problem is, or the issue is, that we have variation in everything, and that's why last Thursday's lecture was so pivotal for you to understand about the idea of variation. Okay, another really important thing. And don't worry if you don't get all this now, because I'll be presenting the same ideas again several times, because it really does take a while for all this stuff to sort of make any sense. And in fact, the other thing is, don't worry if it never makes any sense. If you can still do it, that's fine. It's a step up from an awful lot of people. Okay, so an effect is statistically significant, which is very hard to say if you've got a lisp, when there is evidence from the sample to reject the null hypothesis. So if you say this is a significant result, now unfortunately, in the wider community, if I said this is a significant result, what would you think that meant? Big? Important? Would that be right if I said this is significant? Okay. That's not what it means in statistics, okay? So in the regular world in the media, significant means big or important or newsworthy or, whatever, that sort of stuff. But that's not the case here. So a result where a p-value is less than a level of significance is called a significant result. Okay, so if our p-value is 0.04 and our cutoff is 0.05, that is a significant result. Can you stop talking? A significant result is simply one for which we have evidence that it exists in the population. It may be large or small, and it may be of practical use or not. Okay, so in fact, if you take a large enough sample, even quite a trivial result can be statistically significant, because you've got enough evidence in the sample to say that this result exists in the population. So say we'd taken an enormous sample and we could have shown that females text more than males by only 1 text per day, and that could be statistically significant. So if I tested, say, 5,000 people, we got the same means, but because we'd taken such a big sample, it then became statistically significant, so we could then say that there was a difference in the population. If the difference is 1 text, who cares? It has no significance. Shouldn't say that. It has no practical meaning. So there is a difference between significant and useful or important or large. Really important. A significant result can be small and unimportant. A significant result can be large and important and useful. But the significance is to do with whether we have evidence that it exists in the population from the sample that we've taken.